Hi, Mr. Martusiak here, and right now I want to discuss the atom with you. Now, a few things to think about. What is your understanding of the atom right now? How is it organized? When you think of the atom, how do you think it? How do you picture it in your head? And how are the parts of the atom all arranged? Well, let's take a look at this picture here. Does it line up with what you thought about? The atom contains three main types of particles: neutron, proton, and electron. Now the protons are positively charged particles, and they are in the center of the nucleus. You can see that they are identified by the plus signs inside of the middle of the nucleus. They do have a mass, and they determine the identity of the atom. So if you gain or lose a proton, then you change the identity of the atom. So an example here. No other atom besides carbon can have 6 protons. If you have 7, you have nitrogen. If you have 5, you have boron. And no other atom besides zinc can have 30 protons. If you have 31, you have gallium. If you have 29, you have copper. The number of protons an atom has is also called its atomic number. And the elements in the periodic table are all arranged by their atomic number. You can take a look at the periodic table, and you can see it starts with the number 1, and it goes all the way through. And depending on the periodic table that you're using, you're going to end up somewhere in the 100s, maybe even farther. So the 36th element on the periodic table has 36 protons and 36 electrons if it is an atom, and its atomic number is 36, krypton. But be sure to keep that away from Superman because it's deadly to him. So neutrons. Neutrons are also located in the nucleus. They're neutral in charge, and they do have a mass as well. They exert the strong nuclear force on protons. So they kind of act like a glue that holds together the entire nucleus, the protons all together with the neutrons. And so since the protons are positively charged and like charges repel each other, neutrons are needed to keep all the protons in the nucleus. Ha ha ha. Neutrons. So sometimes atoms of the same element have a different number of neutrons. So let's take a look at lithium here. We have 3 different forms of lithium. And we can tell that they all have different neutrons, or amount of neutrons, by just looking at the pictures there. We can count the different amount of circles there with the N in there. The P's all stay the same, 3, 3, 3. And when we look at the boxes, the 3 in the lithium, bottom left corner there, stays the same in all 3 boxes. But the number of neutrons varies. So all 3 forms have 3 protons, but each has a different number of neutrons. 3, 4, 5. And since neutrons have mass, additional neutrons will increase the overall mass of the atom. You add neutrons, you add mass. And so atoms of the same element, like we saw lithium there, that have a different number of neutrons are called isotopes. And if we take the sum of the protons plus the neutrons, we get the mass number. Now, we only use protons and neutrons because these are the only particles that actually contribute to mass. So now we're getting to electrons here. And electrons are negatively charged, and they're found in the electron cloud. And they have a negative charge to them. And essentially, they have no mass. So we don't count them when we get that atomic mass, or that mass number. So, because if you take a comparison look here, the mass of 1 proton, to get that from electrons, you need 1,835. That's a lot. So electrons determine the overall charge, though, on the atom. But by definition, all atoms are neutral. So, for an atom to be neutral, it must have the same amount of protons and electrons. Positive and negative charges must be balanced. Now, when you get too many electrons, you'll get an overall negative charge. And if you get too few electrons, you get an overall positive charge. So, let's take a look at an example here. We have magnesium, an atom. And look, 12 protons and 12 electrons. So there's no net charge on this magnesium atom. But when an atom gains or loses electrons, it becomes charged, and that's when we call it an ion. So let's take a look at a magnesium ion. The protons stayed the same, because remember, if we change the number of protons, then we'll change the actual atom. So we have 12 protons, and now we have 10 electrons. So now our net charge is a positive 2. We lost electrons, so we lost something that was negative, so we became more positive. Let's take a look at nitrogen ion. 7 protons and 10 electrons. So now we have a net charge of negative 3. Now the nucleus is very small compared to the electron cloud. Take a look at this picture here. The cloud is that blue region there, and the nucleus is that small little red dot. So the electron cloud is much, much bigger. And it says on the H atom, that's the hydrogen atom right there. But the nucleus is where all the mass of the atom is found. So to summarize, protons are positive and they're located in the nucleus and do have mass. Neutrons are neutral, they're located in the nucleus and they have mass as well. Electrons are negative, located outside in the electron cloud, and they do not have mass. The atomic number is the number of protons. The mass number is the protons plus neutrons. And atoms are neutral. They're equal numbers of protons and electrons. Ions are charged. They have gained or lost electrons. And isotopes are atoms of the same element with different number of neutrons. Well, that's it for the atom. If you have any questions, ask me in class.